All right, if you get a function that looks like this, write this down, because then we're going to roll. If you get a function that looks like this, I'm totally making this up. Okay, I have no idea what we're going to get. But without even putting anything in your calculator, the instructions, and I meant for you to do what I told you to do the night before. But what did it say? Find the degree. What's it say? No, that's what I want to look at. It says state the possible number of positive real zeros, negative real zeros, and imaginary zeros of each function. Well, here's what I want you to do. Folks, what kind of degree does this have? It is degree 4, which means it's either going to look like a W or an M, correct? It's going to look something like that. That means, what types of solutions is this going to have? It could have, because there's some options, it could have 4 whats? 4 real solutions. This is what I was looking for. It could have 4 real solutions, meaning there will be 4 whats on your calculator? 4 x-intercepts, 4 zeros. Or, this is what I had to take points off some of you. It could be what? What's the other option? 2 real and 2 imaginary. How do I know if it's imaginary, folks? If it doesn't cross the x-axis. So that means, Anna, that this might look like, and again, I've not put this in the calculator, I totally made this up. But it might look like something like this. How many real solutions do we have? Just 2, because the other 2 are up there somewhere. Okay, and we would have to use the quadratic formula to find those. Or there's still another option. What's the other option? Nope. 0 reals and 4 imaginary solutions. I don't know about you, but I would not want to put that in quadratic formula. Okay? Yuck, yuck, yuck. It's doable, but I don't want to have to do that. Okay? So that's what I was looking for. And this might look something like one, two, three, 4, and this one might look like this. Okay? Just be prepared for what you could see. All right, so you're going to look at the homework site tonight. You're going to look at the Hot Notebook solutions. I will start putting the worked SOL. I need to make sure that I have those on file. I'm pretty sure I do. If I do, I will post those today during planning. So you can print those off at home and start working the problems. Why not? Folks, the next 4 weeks, we only have 4 weeks of school left. We only have like a week and a half before our SOL. You need to do something outside of this class. It would make you feel better. It would make me feel better. You guys are going to be fine, and I know you're going to be fine. But that being said, you guys you want to do well. For the most part, everybody in here wants to do well. Okay? And I know that because you're 10th graders taking Algebra 2 and you're taking Trig next semester. You wouldn't be. Okay? If you didn't care. And I would say 98% of you care. 100% of you care. But some of us care more than others. Yeah. Yes. Yeah. If I put and to what on your papers, then that means you did not list imaginary. And you should have, yeah, because it mimicked the assignment from the night before. Okay? Here we go. Inverses, folks. Inverses. Be prepared at any time to turn work in if I ask for it, homework. So you got to do it. I'm going to try to be very conscious of everything going on this week because it's a lot going on, okay? I know we got lots of ball games and things are getting crazy because it's getting closer and closer to Christmas. But always do your homework, even if you have to do it all during first block. I didn't say that. Head, you should never say things like that. Shame on you. Okay, here we go. If A and B are relations, and this is probably where I started or from Wednesday. If A was the relation, the set of ordered pairs 1, 5, 2, 6, 3, 7. And we want to determine the inverse of A. The inverse, okay? If I give you that A is the set of ordered pairs 1, 5, 2, 6, 3, 7, and I tell you that B is the inverse, then folks, all you have to do, this is very, you better pay attention. I don't want you to miss this. To determine the inverse of the relation, pay very close attention. That's it. Just switch X and Y. So that means that the set B will contain what ordered pairs? 5, 1, 6, 2, 7, 3. That facile or difficile? Yeah, okay. This is easy. Just switch X and Y. Now, taking that a step farther, let's look at it. Is A function? A is a function. Yes. Is B? B is as well. Okay. The X's don't repeat. Make yourself a note there. Okay. Now, what are we going to do with these? That's easy when you're just switching up the values of an ordered pair. That's very, very simple. But if I wanted to look at graphing inverses, things change a little bit. If we wanted to graph an inverse relation, folks, the thing you've got to know is that the inverse is a reflection about the line y equals x. Folks, do y'all know what that line is called? We've talked about it briefly in here. You actually have it in your notebooks, in your binders. What's the line y equals x called? It's called the parent graph. It's called the parent graph. You have a picture of it on that sheet that's in your binder. Okay? But the inverse of a function will be reflected about the parent graph, y equals x. All right, so what's that mean? It means it's been flipped, okay? So if I have this picture, what is that dotted line that I just drew in there? That's my parent graph, right? Y equals x, because where x is 1, y is 1. Where x is 2, y will be 2, because they're equal to each other, yes? If I were to have these values let's say that that was your picture. That was the relation that we had to graph, okay? If I reflect it, then let's say that this ordered pair is, I don't know, 0, 5. Then what's its inverse? 5, 0, which is going to be out here, isn't it? And if I were to say that this value was 2, 5, then its inverse would have to be what ordered pair? 5, 2, which would be up here somewhere. And then, folks, wouldn't we have, this is our inverse. If we took this back to geometry, then this would be our image, and this would be our pre-image. Okay? Graphically, that's what we're talking about. Each of those vertices of that triangle will be an equal distance from that parent graph y equals x. Now that's just showing you what it's gonna, that's y. So let's take an equation, folks. Does everybody have that? Let's take an equation. Let's look at finding the inverse of f of x is equal to negative 1/2 x plus 1. And then we're going to graph the function and its inverse. Okay? So we're going to look at the function. F of x is equal to negative 1/2 x plus 1. What did you tell me to do? What's another way to write f of x? If I were to rewrite f of x as y equals negative 1/2 x plus 1. And what did you tell me earlier that we just had to do with those ordered pairs? And you said, really? Is that it? We what? Switch the x and y. Folks, do the very same thing. Switch the x and y. In order to find the inverse, we just switch the x and y. So here we go. X is equal to 1/2 y plus 1. Now, what do you think we're going to do with that? Negative 1/2. I just made a, sorry. Thank you. What do you think we're going to do now? Because if we got to be able to graph it, we need it in what form? I need it in y equals mx plus b format. So what am I going to do to this equation? X equals blah, 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 blah. What am I going to do to it? Move. I got to change it, don't I? Don't I want to put it in slope-intercept form? So I'm going to subtract 1 from both sides. Y'all with me? And that gives me x minus 1 is equal to negative 1/2 y. Oh, and we've got a fraction. We love fractions. Yes, we do. How do I get y by itself? I could divide by negative 1/2, or That's the same thing as multiplying by the reciprocal. So I could multiply the whole thing by what? Who? Negative 2. I could multiply the whole thing by negative 2. Or divide by negative 1/2. Same difference. The same thing. Okay? And we're going to distribute. So that's going to give us negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. Negative 2 times negative 1/2 is positive 1y, or just plain old y. Now, I don't like the way that's written. Does that bother y'all? Because it bothers me. I want to rewrite it. Y equals negative 2x plus 2. What is that? Okay. But what is that? What did we just create? We wrote the inverse of our original function, which was f of x is equal to negative 1/2 x plus 1, right? And you know, if we start with that f of x notation, there has to be another way to note the inverse function. Do you remember in geometry when we were trying to find sine, cosine, and tangent? Look at your calculators real quickly. Do you see right above there? It's got sine of the negative 1, cosine of the negative 1, tangent. We use it very briefly in geometry to be able to find angle measures, but we have to use the inverse sine or the inverse cosine or inverse tangent. Seeing that notation, how am I going to rewrite y equals negative 2x plus 2 in function notation, showing that it's the inverse? F to the negative 1 of x is equal to negative 2x plus 2. That's just showing that it's the inverse of that function, okay? And y'all, we're going old school. Oh yeah, we're going old school, okay? Here we go. We're going to graph the first function, and then we're going to graph the inverse. So, do you remember how to graph this? Negative 1/2 x plus 1. That's our original function. Negative 1/2 x plus 1. Do you remember how to graph this? We've got to plot the y-intercept first, which is at 1. And from that value, we're going to go down 1, right 2. And down 1 and right 2. Because if it has a negative slope, it has to be a downhill line, right? That's the original function, f of x. Now we're going to graph the inverse. And I've got to plot the y-intercept at 2. And then what am I going to do with negative 2 as my slope? I'm going to go down 2, right 1, down 2, right 1. And then look at that. Now, I've just graphed those two lines without a grid, by hand, no straight edge, no nothing. Let me just make this clear. Is it going to be perfect? Of course not. Okay? I'm doing all this stuff by hand, right on the fly. Okay? But can we see how those two lines appear to be reflecting about that parent graph? This is what freaks me out, and I go, ooh, this is so weird. But if I think about if I were to take my paper and I were to fold it on the blue dotted line, those lines should meet up with each other like this. This top of this green should match up with this red. This bottom red should match up with that bottom green. I have to think of it like that, symmetry, okay? But it's weird. Now, are we going to be graphing things on paper? By hand? No, but I have to do that because I love graphing lines. I love graphing lines. Love it. What are we going to do? What are we going to do? Where are we going to graph these things? In our calculators, okay? We're going to graph all this stuff in our calculators. And folks, you're not always going to have to manipulate an equation to figure out what the inverse is. Because let's face it, if it's a polynomial function of degree 5, do you want to do that algebra? No, neither do I. And now that I am becoming a calculator ninja, I don't want to do it either, okay? All right, so what are we going to do? You ready to see how to do this on the calculator? Get your calculators out. Thank you. All right. Now, some of you will want to write this down. You will actually want to write down the step-by-step instructions. But we're going to, we got our two functions here in front of us, f of x and f to the negative 1. And we're going to put in our first function that we were given, negative 1/2 x plus 1. Be sure that you put parentheses around that negative 1/2. If you don't, put in next. I'm going to put my inverse in there, okay? Now, which is negative 2x, no parentheses in this one. And folks, I want to make these different. So if you'll arrow all the way over here in y2, do you see how you can move it all the way to the left? If you hit enter, I can change y2, my inverse function, to a heavy line, okay? And then, if these are functions, if they're inverses of each other, they are reflected about which line? The parent graph, which is y equals x. So I just want to put that in there. Yep. It should. Yeah, you're there. Yeah, you're there. It's blinking. Oh, okay. Everybody good? So the first line we're going to see graphed is our original function. The second line with the heavy line is our inverse of the original. And then our third line that we're going to see is going to be our parent graph. Everybody clear on that? Yes, no, maybe. All right, you ready? Hit graph. And watch what happens. Here's the original. Here's the inverse. And there is it's actually our line of symmetry. Y equals x. What do you think? It's kind of crazy. Kind of neat. This right here is our line of symmetry. Yeah, you can do that, just as long as you know what you're graphing, okay? Phi-sil, dphi-sil. Phi-sil, if it's a linear equation, you switch up the x and y, you solve, you put it in the graph, boom, you're done, right? All right, now, did we do everything it said? Let's go back and look. We graphed the function, we graphed its inverse, we found the inverse, yes? Did we do everything? So what's part of our answer? This right here, f to the negative 1, that's our inverse, and then the graph. That's part of our answer as well, correct? You'll be all right, okay? Am I going to ask you to graph anything that's going to not be a linear? Maybe a parabola, but I'm not going to ask you to graph a fifth-degree polynomial function and its inverse, because that would be like prison. That would be awful. I would not do that to you. I wouldn't do that to me, okay? All right, here's another one. Find the inverse. No questions at all. Y equals x. That is the parent graph, okay, of a linear equation. That's all, okay? Here's another one. What if I gave you f of x is equal to 3x plus 4. Find the inverse and graph both f of x and its inverse. Do that for me now. What's the easy part? Switch the x and the y. All right, so we've got y is equal to 3x plus 4, and I'm going to switch x is equal to 3y plus 4, subtract 4. I get x minus 4 is equal to 3y. What do I do? Talk to me. Tell me what to do. Divide by 3. And what I do to one thing, I have to do to everything, right? How many of you wrote y equals x minus 4, all of it divided by 3? How many of you wrote that? Well, guess what? That's correct. But I told you way back weeks ago, to prepare for trig, you also have to understand that y is equal to what? Split each piece of the numerator over that denominator. So we could have x over 3 minus 4 over 3, yes? What coefficient's in front of the x? It's there but not there. 1. So it's actually like having 1/3 x minus 4/3 equals y. And I cannot stand for my y to be on that side, so I'm going to rewrite it. And then what's the best way to write my inverse? Using what notation? My function notation, I want to write f to the negative 1 of x is equal to 1/3 x minus 4/3. Now, folks, which is correct? This is a trick question. All of them. This is correct. This is correct. This is correct. This is correct. And that's correct. All of those are the inverses of f of x. Will I require you to write every single one of them? No. But the SOL test may give you, it may go from this straight to this. And you got to know how to get there. Comprende? Facile or difficile? Are we going to graph this on paper in our calculator? Calculator. Folks, do you have any questions on putting this in your calculator? What? I put it in parentheses, just so you can see it. Thank you. But y'all know I'm a big fan of the parentheses. Okay? So what was my original? So I don't even know what my original was. 3x plus 4. 3x plus 4, right? And then I've got 1/3 parentheses x minus 4/3. But I'm a huge fan of the parentheses. And then just watch. Is this what you saw? The original, the inverse, and the parent graph. How many of your calculators look like that? Facile or difficile? Questions? Preguntas? No? Everybody cool? Yep. All right. So, how about this? F of x is equal to 8x cubed minus 6. That would not be. Is that doable? Yes. Bless you. I think I heard a sneeze. Totally doable. If we change this to y equals 8x minus 6, 8x cubed then I'm still going to switch my x and my y, aren't I? Okay, this is my original. But now we're going to switch things up. Folks, what do we still have to solve for? We still got to solve for y. So in order to do that, tell me what I'm going to do. Add 6 to both sides, which is going to give me x plus 6 is equal to 8y cubed. How am I going to get y by itself? Divide by who? That's right. I thought you said. Now I'm going to leave it like this because now I've got something equal to y cubed. How do I solve for y? I've got to take the cube root. Okay. Cube root of one side, what we do to one side, we have to do to the other. And this is where you kind of get like, Miss Perry, really? What? No. Okay, you got to remember what happens. When you take the cube root of a fraction, when you take the square root of a fraction, remember, do you know what you have to do? You got to split it. Very good. Cube root of the numerator over the cube root of the denominator. Y'all with me? You also can't forget about, if this is a cube root and it's a positive, then it's going to remain a positive answer. But folks, can we find the cube root of the quantity x plus 6? And who wants to, right? We don't want to right now. So guess what? We don't. We're not going to worry about it right now. That's not what I wanted to do. We're not going to worry about that right now. So we're going to leave the numerator as the cube root of the quantity x plus 6. But folks, what's the cube root of 8? 2. Now, can we put that in our calculators? Yeah. You have to be a calculator ninja, and you got to be friends with them parentheses, don't you? But this is totally doable. Now, let's rewrite this. Using our inverse notation, just to make it look nice. Let's put this in our calculator. What do we have to be friends with? Parentheses, right? What was our original equation, our function? 8x cubed minus 6. 8x raised to the third minus 6. And now, holy moly, parentheses around your numerator. Remember, your cube root is under math, and it's option 4. So I'm taking the parentheses of the cube root of x plus 6. This ends up being really neat. I'm going to close my x plus 6, and then I'm going to close my numerator, divided by 2. Everybody with me? All right. Let's graph it and see what we get. Our original. It's kind of weird. Are they reflections of one another? Yeah. It's kind of cool. I don't want to graph that thing by hand, do y'all? But you got to be able to look at it and go, okay, there we go. There's the inverse. Questions at all? Any questions? You will not have anything like this that I will say graph it on paper. You may be asked on an SOL test, which of the following graphs appear to be the inverse of this function? And then you have to blow your calculator up. Okay? Yes? Got it? Other questions? Facile or difficile? What's the hardest part about this? Make sure you use your parentheses, okay? And if you put a parentheses in there, you better close it, right? Don't leave it out there hanging. That would not be good. Pardon me? I don't know. Let's see. What if I don't do that one? Probably nothing if I don't do that one. Okay, that one's going to be the same, but I'm never going to take that chance, Christian. What if it didn't do it here? I'll see. That's going to make a liar out of me. Yeah, I'm always going to use my parentheses. Don't give me that look. Use your parentheses. You'd be better off if you do. Okay? All right. I don't know what's going to happen. Just use them. Just use them. It's like washing your hands. Always wash your hands, y'all. Wash your hands. Especially when you come out of the bathroom. Vomit. Wash your hands. Okay, here's one. Look at this. Notice the words that I'm using. How to draw the inverse. Okay? This is your calculator stuff, folks, that you need to, I had to write it down because if I don't write it down, I'm not gonna remember it, okay? Got to have something to refer to. First thing you need to do, folks, is you need to put your y sub 1, your original function is your y sub 1. Put y sub 1 equals the original function, okay? The second thing you need to do is you need to go to second draw. Because, let's just face it, do we always want to do the algebra, and do all of us always get our algebra correct? No. Okay? So I tell you what we're going to do. We're going to go through this on the calculator, and then we'll come back and write directions. How about that? Okay? Instructions. Let's look at the same thing. So I have that 8x to the third minus 6 is my original function, yes? Go to second draw, which is your program button. Y'all see that? What do we want to draw? I don't want to draw any of that stuff up there. But if you go on down that menu, look at option 8. What is that? Draw the inverse. So hit enter. We want to draw the inverse. Well, what do we want to draw the inverse of? Hit your vars beside the program button. All right, hold up. We were here. Okay. Second program, and it's option 8. Draw inverse. You there? Okay. Hit enter. Oh, geez. Now hit your vars, which is right here to the left of the clear button. And folks, go to y vars. Well, which function do we want to draw the inverse of? Back at you. Y sub 1. Hit enter. And hit enter. We put the original function in there. There's my, that was NOS. That was NOS. Did y'all see that graph? What just happened? Did y'all see that? How fast it graphed? Before, it took forever to graph the inverse, didn't it? And that was like turbo. That was like James Bond turbo. Huh? Did you see the movies? They were on the whole time. Oh, there's a James Bond movie? Game? 007. Okay. All right. All right. I don't know what that meant. Okay. Okay. All right. I love James Bond. Okay. Not that anybody cares. Here we go. Second draw. Here's what you do. Second draw. From that menu, you go to option 8, which was draw inverse. And then you'll hit enter. And then you're going to hit your vars button. And from vars, you're going to arrow to the right. And you'll go Y vars, one function, enter, and then you'll enter again. And let me tell you something. If you don't write this down, don't ask me, how do I do it? Well, if you don't write it down, write it down. What's going to happen when you get home and you're doing this and then you go, oh, I didn't remember how to put in my calculator. I'm going to go tough. Write it down. Yes?
You have to have, for like the third one, y equals x.
No. I just put it in there and it was already left in there. But you do not have to have the y equals x. For me, it's nice to see that it does reflect about that line, but it doesn't have to be there. And you don't have to have it there. Okay? What do we do? Yes? To clear your drawing, because remember, we have drawn this in the calculator, and some of you like to draw all this stuff. You like to draw anything other than what we're supposed to be doing. But to clear your drawing, oh, so you already know. Second draw. Is that good? Is that okay? Second draw. Clear draw. That's what you'll see. And that will remove the inverse function from our picture that we're looking at. Okay? Questions at all? No questions? Very simple. Switch X and Y, solve, right? The hardest, you know what the most difficult part for me will be? Because this is something new to me. I get switching the X and Y. Putting in the calculators, that's the most difficult part for me. Because it's something completely new. I didn't have this back in the day. So, we had to do it all on paper. That XY chart, y'all remember that? So you don't even know what it is. We should do that after the SOL. Nope. Here we go. Here's another one. (16x squared plus 1) where x is greater than or equal to 0. I'll put some parameters on here, on this. And I want you to write the inverse. What do we do? What's the first thing we do? Switch to X and Y. And then we're going to solve, right? How do I do that? Talk to me. Subtract 1. And I get x minus 1 is equal to 16y squared. And then what, folks? Divide by 16. I get y is equal to. Now, we're taking the square root. We're not talking the principal square root. So what do we have to be careful about with our signs here? We don't have to worry about it with an odd power or an odd root, but when we're taking the square root, don't we have to be mindful of that plus minus? Okay? In a minute we do. In a minute we do. Why in a minute? Because I got to do what to both sides now to solve for y. Now I'm going to take the square root of both sides. And now's when I have to be mindful of that plus minus. Split your numerator over your denominator. And folks, what will our inverse be? Square root of x, the quantity x minus 1 over what? 4. And that's our inverse. That's how we find the inverse algebraically. Now, what's it going to look like with our calculators? What do we have to be careful about here? The plus or minus. So how many curves will I have to put into my calculator? I'll have to put my original, which was what I was given up here, y equals 16x squared plus 1. But when I draw my inverses, how many of those will I have to draw? 2. One to account for the positive and the other to account for my negative. Are you with me, yes or no? Yeah? Okay. Calculator. Oh, Lord, have mercy. Yep. Not necessarily. No, because why does x have to be greater than 0? Look at what we're given. Why does x have to be greater than 0? Our y value can be positive or negative, but our x value has to be 0 or greater. It has to be greater than, right? Why? What is the square root of a negative number? An imaginary number. That's why that stipulation's put on there. Okay? And it's on the original function. Now, let's put this in our calculator. Lindsay, do you mind? I'm sorry, but I appreciate it. All right, here we go. Clear this thing out. I'm going to clear out my x. And our original function is 16x squared plus 1. 16x squared plus 1. Y'all cool with that? Now, let's see how we're going to put this in. Oh, let's see if I remember how to do this. Second draw. Did I clear my drawing? I don't know if I did or not. All right, second draw. I want to draw my inverse. And I'm going to hit my bars. I'm totally thinking this through out loud. We go to y bars. No. Which is not a function? Ooh, that's a good question. Which is the original? The upward turned parabola or the sideways parabola? The upward turned parabola is the original. And if I touch this, you know it's going to go. Happy Monday to you too. Y'all totally threw me under the bus. Y'all were hateful. They all looked, and I went, what are they looking at? Don't do that. Somebody needs to give me like the, you are fart face. Love you.
Here's what happens.
Well, now, when we look at the original function, and it is the upward turned parabola, the original function, is it a function? Is it? Yes. The original is a function because it looks like this. And if you use the vertical line test, it only crosses once. But the inverse Look like that, correct? Is the inverse a function? No. Vertical line test tells me no. Okay? I'm still thinking what he said. Yeah. Questions? Don't look at me like that. All right. That just makes me laugh. I think it's hilarious. All right, so we're done with that one. Let's go clear a drawing. Oh, what does this look like? We've already looked at it. Clear the drawing. It's like it's a big... Clear the drawing. No, that is going to clear. If I, just what I did. When I went to y equals and I cleared out my y sub 1, that's my original function. What did I draw? I drew the inverse, so I had to clear that drawing off of my screen. Okay? Let's look at something else. I don't know what example number this is. What is this? 5. Okay, let's look at this one. What if we had f of x is equal to negative 5x over 7 plus 2? And you've got to write the inverse. How am I going to do that? All right, so switch your x and y. What are we going to do? You want to get rid of that denominator immediately. Immediately. I want to do something before I do that. Bless you. I want to move the 2 first. Let's move the 2 first. Can we do that first, Dante? Is that okay with you? I guess. Now what do? Get rid of the denominator. Y'all do not like fractions, and I cannot figure out for the life of me why. What you do to one thing, you got to do to everything, correct? So multiply by 7. That's going to eliminate, and when we do that, folks, we're just distributing, yes? 7 times x is 7x. 7 times negative 2 is negative 14. You're creating such another step here. My 7s will eliminate, so now I don't have a fraction. Hoo, lolly, lolly. But I'm still not done because now I have to do what? Divide by negative 5. Weenies. That's going to give me what coefficient of x? Negative 7/5. What's negative 14 divided by negative 5? Positive 14/5. Right on. And my inverse, everybody with me, yes or no? Y'all cool? My inverse, f to the negative 1, negative 7/5 x plus 14/5. I am totally okay with that. I wish y'all were. By the spring, y'all are going to so totally love. You're like, fractions. It'd be like leaping through a meadow full of daisies. Questions? Sure. Here's another one. Are we cool? Here's another one. I think this is example 6. If your function is the square root of x plus 3, where x has got to be greater than or equal to, you tell me. What do you think it's going to be greater than or equal to? Negative who? It's going to be negative 3. Because we don't want it to be negative, right? Be an imaginary number. Find the inverse. What do we do? Before we square anything, what do? Switch the variables. So x is equal to the square root of the quantity y plus 3, yes? And now what? Now square everything. Why are we squaring everything? It's the opposite of square root. And what are we trying to get by itself? The y. So we get x squared is equal to y plus 3, right? For what? Minus 3. Why? We want y by itself, so that gives us x squared minus 3. Or, if I wanted in function notation, f to the negative 1 of x is equal to x squared minus 3. How could I check that? Calculator. And why wouldn't you? Once you do the algebra, couldn't you put that equation in your y sub 2? And couldn't you also draw it? And if you have algebraically solved it correctly, you won't even know. Yeah, I just want to make sure I was saying it right. Would you see any difference in your inverse function? No, you wouldn't. Okay? So you can always check with your calculator. Questions at all? Okay. Here's another one. How do we tell if functions are inverses of one another? If I wanted to determine whether these two were inverses of one another, okay? Here's what you need to do. Because you're going to be asked to do this. This is a word we love. I saw some of you roll your eyes. How to prove that f of x and f to the negative 1 of x are inverses of each other. All right, this is what we're going to do. It's going to go back to function notation, composition of functions. If f of g of x, we're going to find f of g of x and g of f of x. I'm doing that. You got to find both of those. Each of these should be equal to x. If each of those are equal to x, then the original function and its inverse, they are inverses of each other, okay? Bless you. Because sometimes you're going to be given two random equations and you're going to have to be taught, or you will have to prove that these are inverses of one another, okay? So let's check. We're going to kind of go through the back door to figure this out, or to show you how to figure it out. So our original function is x plus 4. If I wanted to find the inverse, what would I do? Switch the values. So x is equal to y plus 4, correct? And my inverse becomes, after I subtract 4, I'm going to get y is equal to x minus 4, yes? So that means my inverse is x minus 4, correct? Everybody with me, yes or no? All right. Now this says, how do I prove? This says, in order for me to prove, and I've just figured out what the inverse was. So are they going to be inverses of one another? Yeah, they're going to be inverses of each other. But now we've got to show it. We've got to prove it. Okay? So what we're going to do is we're going to take, we've got our inverse here. Our original here. Just for good measure, I have to put it there. We have to figure out f of g of x. Remember how to do this? This is like substitutional steroids. Bless you. What's my g function? Okay, there's not a g function. What do I call my g function then? It's what? That's my inverse. My g function is my inverse. So you think g of x, okay? So my inverse is x minus 4, right? That's my inverse. Now I've got to substitute x minus 4 into my f function. So that's going to be x minus 4 plus 4. Y'all with me? You seeing what I'm doing? Think about it and process. Combine like terms, what do you get? X. So f of g of x is indeed equal to x. Think about what we're doing. Now, we've got to find g of f of x. What's my f function? My f function is x plus 4, so I'm going to take g of x plus 4. And I'm going to take x plus 4, and I'm going to plug it into my, which function? Into my g function, which is the quantity x plus 4 minus 4. Process and think about what I'm doing. All this is substitution on steroids, folks. That's all. Combine like terms, what do you get? X. So they're both f of g of x, g of f of x, they're both equal to x. Are they indeed inverses of one another? Well, yes, we knew they were going to be. They have to both equal x. They can't both equal 2. They have to both equal x. Good question. Are inverses of one another. And that's what we were looking for. That's how you prove it, folks. And what are they going to give you? Who knows what they're going to give you on the SOL? Who knows? They may give you two, f of g of x, g of f of x, and say, hey, you got to figure out whether they're inverses of one another. You got to know how to do this, okay? Here's what I want you to do. If you will look at, does everybody have that before I move on? I want you to look at the workbook, folks. Page 86. One through 9, 12, and 15. For the next week and a half, you're going to be doing a lot of work, okay? I'm going to post all that stuff online for you. Even if you don't want to, you need to be working on this. Let me just ask this question, and then I'm going to hush. If I were to find in a problem that f of g of x was x, nah, is 4. Okay, I'm given two functions, the f function, g function, and I'm told determine whether they are inverses of one another. And I immediately find that f of g of x is 4. Do I need to go any farther? Do I need to find g of f of x? Why not? Because it doesn't equal x. So we would be done. Not inverses. I don't want to do unnecessary work because the composition of the functions both have to equal what? X. It's exactly what Courtney was just asking. Work on this now. Don't just pack up and chill, although we want to, okay? Use your time wisely.